now that you've had some experience looking at representing numbers in different bases, we're going to use our understanding of different bases to do some arithmetic. So we're going to look at the arithmetic operations on numbers, addition, subtraction, multiplication, division, including look at some conceptual models where that is helpful. We're going to show how to do computations with different bases without converting first to base 10. And we're going to do some examples. So let's remember how addition works in base 10 when we're adding in large numbers. We basically add numbers by adding each individual place value, and then we trade in when we get more than 9 of a given place value. So if we're doing 256 plus 785, we split this into the hundreds, the tens, and the units. And then, well, we start trading on the units because we have 6 plus 5 units. We have two hundreds plus 7 hundreds. We have 5 tens plus 8 tens, and then we have 6 units plus 5 units. So we can combine the hundreds into 9 hundreds. We can combine the tens into 13 tens. And when we look at that 6 plus 5, it's convenient to think of that as 110 plus a unit. That enables us to see that we have 1 unit left over, and then we can take that 10 that's left over and combine it with the 13 tens next to it. That gives us 14 tens. We can play the same game with the 14 tens, split that into 104 tens. We can combine that 100 with the 9 other hundreds to the left of it. That gives us 10 hundreds. And then we can make that 10 hundreds into 1 1000. And now we have everything the way we want it. We have 1 1000, we have 0 100s, we have 4 tens, and we have 1 unit. We're going to do that same process when we add numbers in other bases. So if I'm doing 6355 base 7 plus 4536 base 7, we're going to do the same thing. We're going to group together the ones that have similar place values. So we have 6 1000 base 7 plus 4 1000s base 7. We have 300s plus 500s. And we have 5 tens plus 3 tens, and then our units are 5 plus 6. So once again, we can combine those. Now when we combine the 6000s plus the 4000s, remember, we're in base 7. So instead of thinking of that as 10, we're going to think of that as 1 3. When we combine the 300s and the 500s, that's going to give us 800s, but in base 7, that is 1 1. And similarly, we have 1 1 tens. And then when we do 5 plus 6, that's 11, but that is 1 4 in base 7. And now we go ahead and trade up. We turn that 1 4 into 10 plus 4, 10 base 7 plus 4. We combine that 10 plus base 7 with the ones that are next to it. We get 1 2 base 7s and then 4 units left over. 1 2 tens plus 4 units left over. We can split up those 1 2 tens into 10 tens plus 2 tens. Now remember, 10 times 10 is 100, so that gives us 100 base 7 plus 2 tens in base 7 plus 4. And then we can take that 100 and combine them with the 1 1 100s to the left of it. That gives us 1 2 100s. We can split up the 1 2 100s into 1 1000 plus 2 100s. Combine that 1000 with the one next to it. We get 1 4 1000s. Split that up similarly. We get 1 10,000. We get 4 1000s, 2 100s, 2 tens, and 4 units in base 7. And that gives us the number 14224. For multiplication, it's going to be a little bit different. We're going to use a slightly different conceptual model to help us out. One way of thinking about multiplication is thinking of it as repeated addition, and for small numbers, that works pretty well, right? So if I have 4 times 3 in base 6, we can think of that as 4 plus 4 plus 4. That's 12 in base 10, but in 6 that is 20. Or we could think of it as, instead of adding 4 3 times, we can add 3 4 times, and that again will give us 20 base 6. That gets a little bit harder for larger numbers, but for larger numbers, we can use what we call the area model. So if I want to do 4 times 3, one thing I can do is I can take a length of 4, a length of 3, and then put those together into a 4 by 3 rectangle, and the area of that rectangle is going to be 4 times 3. And you can see that if we break that into 1 by 1 squares, you can count those. Those are 12 squares, 20 base 6 squares, just like we did with repeated addition. And keep in mind the 1 in this case, the number 1 in area is represented by a 1 by 1 square. Right, so our area is 4 times 3, which is again 20 base 6. So sometimes when we do, what we were doing over in the previous is we were taking our lengths, our 4 and our 3, and combining those with a multiplication into an area. Now, sometimes it's helpful to think about, well, how do areas compare to lengths of the same numerical value? In other words, if I have something of length 1, how can I make something that has area 1? Well, that's actually pretty straightforward for the 1. 1 in area is just a 1 by 1 squared. But 2 or 3 can be a little bit trickier. We don't want that to necessarily be a square. We're just going to make that a skinny rectangle. If it's 3 length, 3 by 1 gives us an area of 3 as well. So that works out fine. And in general, if you have some length n, if you want an area that has area n, the easiest way probably to do that is n by 1. All right, so keep that in mind as we do our multiplication. Now, if I want to multiply 1 3 base 5 times 4 base 5, that's not a huge number. We could probably do that if we wanted to just by repeated addition. But if we want to do that with the area, it turns out it makes it a lot easier. So I'm going to make it a 1 3 by 4 rectangle, right? And figure out the area by splitting it up into convenient pieces. And we'll see what that means in a little bit. So here's 1 3 by 4. Convenient pieces means taking advantage of how we understand place value. So the 4 is fine. That's just in units. But the 1 3, we can think of that as a 10 base 5 and then plus 3 base 5. And we can split that up on the bottom. So there's a 10 on the left, a 3 on the right. And I put a little hash mark in between those. And I'm actually going to take that hash mark, keep going vertically, split that area up into 2 rectangles. And instead of finding the area of the entire rectangle just at once, I'm going to find the area of the 2 individual rectangles. The one on the left, the one on the right. Now the one on the left, if you look at it, again, the height is 4, and so we can break that up into 4 rectangles. Each of those rectangles has height 1 and width equal to 10 base 5. And then the one on the right, I'm just going to split up into units. That one's not so bad. That's 4 by 3. That gives us 4 times 3, which is 12, which is what? 2 base 5. So the one on the right is not going to be too bad. That's just regular old multiplication. The one on the left isn't going to be bad either. We have 4 of those skinny little rectangles. Each of those is going to be 10 base 5 by 1, which means it's going to have an area of 10 base 5. There are 4 of those, so we get 4 times 10 base 5, which gives us 40 base 5. So that's the area of the part on the left. On the right, we have just 4 times 3, which is 2 base 5. And we just then have to add those two together. 40 plus 2 gives us 2 base 5 just by doing our regular addition. All right, so that takes care of multiplication. Now let's see what happens when we have some, unpleasant division. So if we have a division problem, say 1311 base 4, and we want to divide that by 3, that's not an easy one to do in our heads. Let's see if we can find some effective ways of doing that where we don't just have to count all the way up to 1311 base 4 and deal them out into 3 piles. But first I want to think about what model we want to use in order to do that division. And there are several models that we could use. The one that I am going to use is, let's say we have 1311 cookies, and we have 3 friends, and then the question is, if every friend gets the same number of cookies, how many cookies do you give each friend? So that's what the division problem is looking to do. So I want to keep track of 2 things. I want to keep track of how many cookies I've dealt out, so I know when I get to 1311, and I want to keep track of how many cookies each of my friends have, but I don't want to deal them out 1 cookie at a time. Oh yeah, by the way, no cookies for you, just your friends. All right, strategy. We're going to deal out several cookies at a time, as many as we can given our place value constraints. So what we're going to do is we're going to split out that 1311 into 1 1000, 3 100s, 1 10, and 1 unit. Now, you can see pretty clearly that we're not going to be able to deal out a 1000 at a time because we just have 1000. And we have 3 friends, so we can't deal those out 1000 at a time. So the natural thing to do is to take that 1000 and break it up into hundreds. How many 100s? Well, it's going to be 10 100s, 10 base 4. So that gives us 13 100s altogether, that 10 base 4 plus the 300s we had before that, plus the 110 and plus the 1 unit. So now 1, 3 in base 4 is 7. That's enough that we can deal out to our friends. So we have 7 groups of 100 cookies. So we're going to deal out our cookies 100 at a time. So when we do that, we deal out 2 of those 100s to each friend, right? We have 7, we're going to deal 2, and that leaves 1 left over. So we've dealt out 2 100s to each friend. We have 1 100 left, 1 10 left, and 1 unit left. Now, once again, we're all done dealing out 100s, 100 at a time, I should say. So we break that up into tens. We get 1 0 tens. Add that to the 1 10 we had before that. We have 1 1 tens and then 1 unit. Now 1 1 in base 4 is 5. So we have 5 tens to deal out. We can deal out 1 to each friend. That leaves us with 2 tens left over and 1 unit. Now we're done dealing out tens. Now we got to put everything into units, but that's okay. That's just 2 1 units, 2 tens, 1 unit. And in base 4, that is 9. So that means we have 9 cookies to deal out. That's 3 more for each friend. So all of our cookies have been dealt out. If we add up all the ones that each friend gets, they got 2 100s at the beginning. Then they got 1 10 in the second stage. And then they got 3 units in the third stage. We put that all together. We get 2 1 3 base 4. All right, so now I think you're ready to work on the activities. The name of the PDF that you're looking for is Arithmetic.